All right, guys, we're going to go through our electron configurations. So the electron configurations, one way to think about this is electron configurations are a way to write the address or the location of our electrons. Okay, so really what we're going to do is we're going to use our periodic table to understand what our valence electrons are, where our electrons are, and how they are interacting. Because this is these different ways that we write these electron configurations are going to tell us, they tell us a lot of information about how the electrons are going to be able to move or interact with something else. Okay, so we have 4 different sublevel types. Okay, so we have S, D, P, and F sublevels. Okay, so what we're going to do is we're going to kind of build this up. Okay, so as we build it up, we're going to have to follow some rules. So the first thing that we have is we have a principal energy level. Okay, so the principal energy level is the same generally as the period that we are in. Okay, so whenever we add an electron, the electron goes into the first energy level. Okay, this is similar to our Bohr diagram, right? So if we draw our Bohr diagram, the first electrons have to go into the first energy level. Okay, so whenever we have the first energy level, we only have one sublevel type, okay? And this type is our s orbital, okay? So hydrogen and helium are in the first energy level. They have electrons that are in the first energy level at their ground state, and that first energy level, we know, can hold 2 electrons. So s orbitals, whenever we have an s orbital, it can hold 2 electrons, and there is only one type of s orbital. So we only have one s orbital. So the total number of orbitals is just 1, right? 1 is 1 orbital. And in each orbital, we can contain 2 electrons, okay? So if we think about this, on our first ring of our Bohr diagram, we can put 2 electrons. That's because, and that corresponds to our first energy level can contain 2 electrons, and we have an s orbital, okay? For the second energy level, we actually have 2 types of orbitals. Now we have the s and the p orbitals. Okay, so s, anytime we have an s orbital, we have 1 orbital, and with 1 orbital, we can only contain 2 electrons. So we get 2 electrons in our s orbital. P orbitals, we actually have 3 orientations of the p orbitals. Okay, so those 3 orientations means that we can get 6 electrons into our p orbitals. So our total number of orbitals, 1 plus 3 is 4, and in our 3 p orbitals, we can get 6 electrons, so we get 8 electrons total. Okay? As we continue here, we'll get up into our third energy level. Third energy level, we must then have s, p, and d orbitals. S, we have only 1 orbital type. P, we have 3 orientations. So if we follow the pattern 1, 3, we have 5 orientations of the d orbitals. So if we add all of those together, 1 plus 3 plus 5 means that we have 9 orbitals total, which means that we can fit 18 electrons. Okay? So then finally, let's go and look at our fourth energy level. Fourth energy level, we have S, P, D, and F. So you'll see as we increase our energy levels, we increase our orbital types that we have. For each orbital, S can only have one orbital type. P only has 3 orbital types. D has 5, 1, 3, 5, 7 F orbital types. If we add that all up, 1 plus 3 plus 5 plus 7, we have 16 total orbitals and 32 electrons that we can fit into it. Okay, so each orbital can contain 2 electrons, and we have our S, P, D, and F orbital types. So let's figure out and use our periodic table now to start filling in our orbitals and identifying our electron configurations. So I'm going to keep this periodic table handy. If you guys have a periodic table, you should look at that. But when we go to write an electron configuration, we're going to use our periodic table. So the first thing that we need to know is how many electrons are going to be in the configuration total. So the first 2 electrons can go into the first energy level. This energy level is the same as an S, or has an S orbital, and so we would write the electron configuration as follows. So we have our first energy level. That first energy level has an S orbital, and then we have 2 electrons. You'll see that's a superscript with 2 electrons that can fit into that S orbital. So 1 corresponds to the energy level, and it is similar to the first circle on the Bohr diagram. The S tells us the orbital type, and the 2 tells us the number of electrons. So here, if we had 2 electrons, which element only has 2 electrons? If we look at our periodic table, that would of course be helium. Helium's electron configuration is 1s2. This is our electron configuration for the ground state for helium. Okay, so if we look at our first period, we have hydrogen and helium. The first energy level can fit 2 electrons in it, and we have hydrogen and helium, 2 elements in it. All right, now let's go on to the second row. So the second energy level, we said, can contain 8 electrons. This energy level has S and P orbitals. S orbitals can only contain 2 electrons, but P orbitals have 3 orientations, so they can contain 6 electrons. So then we would write our electron configuration like this. First, we fill in the lowest energy level first, so our 1s with 2 electrons. Our second energy level then, we have our S orbital type and our P orbital type. Our S orbital type can contain 2 electrons, and our P orbital type can contain 6. So note that the second period on the periodic table contains 8 elements. So if we look at our periodic table, we have 2 elements that are over here on the left-hand side, lithium and beryllium. Those elements are filling in the s orbitals first, the second energy level s orbitals. Then we go and we start to fill in the p orbitals over here. When we fill in the p orbitals, you'll see that we have 1, 2, 3, 4, 5, 6 elements. P orbitals can contain 6 electrons. So now, if we look at this electron configuration, we have 1s2, we count across, we can follow on our periodic table along this electron configuration. 2 electrons, 1, 2 elements, 2 more electrons, we move 1, 2 further, 6 more electrons, 1, 2, 3, 4, 5, 6. This would be the electron configuration for neon. All right, let's look at the third energy level in the next video here.